Hey, my name's Brian. I work on the growth team here at Castle, and today we're going to talk about using the right tool for the right job. When it comes to security solutions, there's a lot of different things you might be trying to tackle, whether it's bot detection or more specifically protecting against account takeovers or registration spam. There's different techniques, different tactics that work better for certain scenarios, and at the same time, each one might have their weaknesses for other scenarios. So we're going to spend 10 minutes today jumping through a series of different scenarios. We'll do a few demos and we'll show how, depending on what you're trying to achieve and what the outcome is you're looking for, there might be a different tool for each job to tackle it. So really quickly, a little bit of background. When it comes to bots, attacks, automation, there's been a series of evolution over the last 20, even 30 years. It starts with automated scripts where you can program bots to automate any sort of behavior you want against APIs, against an application. And this is really where bot detection first came from, was just trying to detect basic sets of automation. And a lot of times these automated scripts were coming from, an obviously scripted environment. They weren't being run from a browser. They weren't being run from a mobile device. So there were certain differences in the heuristics of a scripted environment versus a more human-like environment where humans interacting with a GUI or with a client. But over time, these bots became more sophisticated. You have more emulators. You now have bots that can run in a full Chrome browser. So some of those heuristics start getting blurred between what's bot and what's human. To take it a step further, attacks started becoming more targeted. I think right now a lot of times we see security in one bucket and fraud in another, but really they're one and the same, where you have bots or automation that is actually doing targeted fraud. So if you think of something like an account takeover where somebody is brute forcing or credential stuffing their way into an account, and then maybe doing credit card stuffing, trying a series of credit cards, stolen credit cards to make purchases with. This is very targeted, where the attacker knows what they're trying to do. They know how to get in. They know how to extract value from an application and complete the job that they're looking to do. So this evolution of sophistication and precision targeting also came with an evolution of security, bot detection tools to try to keep up with that pace. So we're going to look at some different tools today. We're going to talk about traditional bot detection and then how you can layer that on with additional technologies such as machine learning, such as behavioral analysis. And we'll see how you can take these different tools and apply them at the right scenario at the right time to better secure your application and better protect your users. So starting with traditional bot detection, as mentioned earlier, traditional bot detection kind of had this assumption that bots were coming from a scripted environment, and it tried determining what's the difference between a scripted environment and the type of clients that a human is usually interacting through. When I say client, I'm referring to a browser, for example. And so some of the things that traditional bot detection would look for is the user agent. Does it look like a legitimate user agent that represents a Chrome or Safari or Firefox browser, for example? It would look for plugins. Are there valid plugins that are available, or is there an odd set of them? It would do browser fingerprinting and JavaScript evaluation. Does the client have the capabilities of executing JavaScript, whereas maybe a Bash script or a Ruby script or a Python script can't execute that JavaScript on its own? You can also take it a step further and look at keyboard interactions and mouse movements and the heuristics of those, and try to see, even if it is an emulator, does the emulator give away clear signals that it's a pre-programmed emulator, because the mouse movements don't seem human-like and fluid enough, or the keyboard strokes are very patterned, whereas humans have a little bit of nuance in how we type. So I think most people are familiar with this traditional bot detection. And some of the weaknesses in it is you don't have a lot of visibility into false negatives. It's clear when you detect an attack and those true positives are quite obvious, but anything that slips through the cracks, you don't have a lot of visibility into until much further down the line. Once maybe a series of fraud or series of attacks has been committed, you then go back, you analyze the data, and you realize what might have slipped through. So security is often kind of in this cat and mouse cycle where the attacker is always a step ahead and then security tries to catch up. So you have a bit of this slower cat and mouse cycle just because of the fact that it's not very apparent when you have a false negative, when things slip through the cracks. On the opposite side of that, as these sophisticated emulators started rolling out, it blurred the line between what's a human and what's a bot. So if you do want to increase detection, it kind of means you have to take a risk and tune up the sensitivity of the security tool. And this can lead to high false positive rates, where if it's not very clear, script or bot, you're going to be a little bit over aggressive, and then you're going to result in false positives. So one thing I do want to talk about is context-aware fraud detection or context-aware security. So what this concept is referring to the specific point in an application where a particular type of attack or a particular type of fraud is being attempted. So for example, if we're talking about registration, if your app is being hit with a wave of fake accounts being created, registration spam is coming in, well, what we know at registration is your app might require an email address. So if you know that there's a particular piece of data that's going to be coming in, you can apply more scrutiny to that particular piece of data. You can do more validation of the email address. You can do things like looking up if the email domain is associated with known disposable email addresses. That's common with spam. Or if we're looking at the point of transaction, or where people are updating their profiles or updating their billing information to put on a new credit card, you might be aware that your application has become subject to a lot of credit card stuffing attacks. With credit cards, you know that you're going to get a credit card number, you know that you're going to get other bits of billing information, so you can apply more scrutiny on all of that information. So you still want to have the bot detection there, but if you know where the attacks are coming, then you can start looking for different bits of data or metadata that you can be certain are going to be passed in there, and you can do more targeted scrutiny and validation of that data. Let's take a look at what that looks like. So I'm going to jump over to this demo application here. What we have here is basically an app inside of an app. So I have this demo piggy bank app here, and I go and I'll refresh this, start fresh here. What I'm going to do is I'm going to simulate a sign up. So I'm going to go ahead and register as if I'm doing a new account here, brian@gmail.com. I'll put a password in and sign up. Okay, so here we're seeing I was able to sign up. You can see security solution when we sent a registration attempted event, security solution evaluated it and said things look safe here, allow this registration to occur, and then an automatic login occurred, and now I'm inside of the application. Now let's look at what happens if I do another registration. The same thing. The only difference is this time I'm going to use an email domain that's amail.com. Now, amail is a domain that used to be used often with registration spam. It was a disposable email domain. There's not a lot of actual people that use it other than for disposable emails and getting these one-time receipts sent to it. So what we can do is we can tune the security solution to say, at the point of registration, where I am right now, for the email address that comes in, do a lookup on the email domain. Check if that email domain is known as a disposable email domain. And if so, let's step up the friction for it. So I'm going to do it right here. I'm using the same device, same environment that I just did the previous registration for. I'll attempt to sign up. And this time you can see security solution received information that a registration was being attempted, but this time a challenge was returned. So that shows how just that little tool, you don't need a huge amount of sophistication, but you can still challenge it by doing a little bit of extra validation. Now, if I take a step back, you still do want, traditional bot detection endpoint here. So let's do one more demonstration. I'm going to create a simulated bot environment. I'll create this device. And what I'm going to do here is run automated registration. And in this scenario, what you want to be able to do is still provide friction in case it is a bot, even if it's not using a disposable email address. So if I go ahead and run, you can see now the bot is doing this registration here, brian@gmail.com, and now it's still being challenged. So that shows you how you can do the bot detection. You want to have that traditional bot detection in place, but you also want to do context-aware detection. You know that there's an email address coming in. That's a simple bit of information that you can apply some scrutiny against, and you can detect attacks that way as well. Jump back to slides here. So that's one example of a tool doing this context-aware detection. But what are some of the weaknesses with that? Well, for one, it relies on having up-to-date data. That amail.com domain, it's a disposable email domain, but what if the tool wasn't up to date? What if it wasn't maintained? New disposable email domains are rolling out every single day. So if you're not manually maintaining that, then it can become out of date, and ultimately it's not very valuable if you don't constantly have a list that's updated and that is maintained properly. Another issue is when you're doing context-aware detection, you're usually doing this at a very business-critical conversion event, registration events, transaction events. These are events that you do not want to have false positives in because there's a very high cost of those false positives. If your solution is becoming over-aggressive, or if there's an error in your database of disposable email domains, for example, and you start blocking Gmail domains, you're going to be blocking out a lot of new signups, a lot of new conversions for your application, and that's going to create some tension between the security team and the growth team, the security team and the product team. And you're going to end up in postmortems trying to explain why your security tool is preventing users from signing up or is locking users out of their accounts. So whenever you're doing the context-aware fraud detection, you need to make sure you have a tool that you can trust, a tool that you can control, because you're really talking about business critical events and you need to be very sensitive around those. Let's look at another technology that has come about. And this one is real-time machine learning. One of the challenges we talked about with the context-aware fraud detection is this necessity to constantly be maintaining a database of known disposable email domains or known fraudulent credit cards. But what happens when a new attack shows up and it's coming in a quick wave and you don't have time to do these lookups? You don't have time to add new things to your deny list. Here is where machine learning can really help out, where it can start to do the pattern recognition and try to figure out where an attack is coming from, identifying a source signature of that attack in real time. So if you have a solution applied across your application, what it can do is recognize when there is a wave of an attack coming in. It has this volume awareness, and it automatically kicks off trying to figure out, are there any patterns associated with this wave that might be a possible attack? It can look for patterns, for example, in the user agent or in the IP addresses, or it can do more clever backend fingerprinting and HTTP header analysis to look for any patterns where you might be able to group a chunk of the traffic together and start denying that traffic that you can determine is associated with the wave of the attack. All right, let's look at that in action. Come back to the demo here, and I'm going to refresh our environment. And this time we are going to simulate a credential stuffing attack. So a credential stuffing attack is where an attacker has gotten hold of a list of leaked credentials. It could be leaked credentials from another site, maybe from an old Yahoo breach or something years ago. But they're going to try this list of credentials, username and passwords, against my login form. And they're going to run through hundreds, thousands, or millions of attempts to see if any of those old leaked credentials are actually valid against my application. So let me start this attack here. And what you're seeing down here is a wave of failed logins occurring as we rotate through all of these attempts. Now that's normal. In a credential stuffing attack, on average, only about 1 to 3% of the attempts are actually successful. So what your security solution can be aware of is whenever you see this wave in failed login attacks, that's probably indicative of an ongoing credential stuffing attack. And right now the machine learning is kicking off and trying to figure out, is there any pattern of this attack so it can detect it if should there be a successful login. So let's take a look now. The attack is run, and now what I'm going to do is I'm actually going to log in with a user where I actually do know the correct username and password. So let's see what happens. I'm going to try to log in now from a similar device that was involved in the attack, and we'll see what happens. Okay, so here it's showing login failed. But if we look at my logs, you can see it shows login succeeded. So I actually did type in the correct credentials, but what happened was the security solution recognized that this device was involved in an ongoing attack, and it denied the login attempt outright. So this is where you can really see the power of real-time machine learning. It recognized there was a wave of an attack underway, it determined the signature, and when it saw a successful login attempt coming from that same signature, it denied it outright. And just to show, if I were to create a new device here, this time it'll be an Android device coming in from Paris. I'll create the device, and I'm just going to try with those very same credentials. This time I'm challenged. So this time it's doing a challenge because it recognized that I came in from a data center. So again, a bit of a suspicious device. And if I do one more, this time I'll come in from a US IP. This is a Windows Firefox device. I'll create this one, and let me try one more time. And I'm challenged again. So you can see how it can tune this friction. You're either going to have more aggressive friction when it realizes that it's part of a clear credential stuffing attack, or when it's just an anomaly. If it's just a little bizarre, there's nothing inherently bad about this Android device or this Windows device, but there is anomalous behavior associated with it. So what are some of the weaknesses maybe involved in real-time ML? Where are some of the areas you might not want to always deploy it? For one, it relies on huge volumes of data. If you're going to be looking for these waves of attacks and analyzing them, you need a system that can really handle that and ingest all of it. And on top of that, there are cases of false negatives. If there was going to be, a one-off attempt, if maybe I got caught up in a phishing scam and somebody did get my username and password and they went to log in on their own, then in that case, that might slip through the cracks. Machine learning isn't going to be great at looking for these one-off cases. It's much better when you can feed it a large volume of data. It can do its pattern recognition and detect the attack. So really good for big waves like credential stuffing, not so great for one-offs like a single anomaly or maybe a phishing attack, for example. It also is very infrastructure and data science intensive. Because of the volume of data that we're talking about, it's very expensive to set up. It's very expensive to maintain. So if you're a smaller team or you're a single business, creating your own dedicated infrastructure for this and hiring multiple PhDs to really get this thing up and running is going to be quite costly for a single business to own and maintain. So that is one of the big drawbacks of going this route. Another interesting advancement is looking at UBA technologies, user behavioral analytics, user behavioral analysis, and applying it to security. So this is where the security tool needs to have a bit of identity awareness. It needs to be able to know the user ID, for example, and start building a profile for that user of what is normal for this user. And if it can build a pattern of behavioral norms for an individual user, then what it can do is recognize whenever there's an anomaly from their normal behavior. So this is where you're able to do things. You might be familiar with your Gmail account when you're getting an email saying, hey, we noticed a suspicious login from a new device or from an unusual location, or maybe there's a fast travel pattern if you're logging in from one location and then instantly there's a login from a faraway location faster than a human could actually travel. This is all related to behavioral analysis. So let's see how that can be used to cut down on those maybe phishing scams. If you do get caught up in a phishing attack, UBA can really be the good tool to help protect against that. All right, we'll jump back into the demo here. And what I'm going to do this time is I'm first going to do just an initial login to kind of set a baseline for this user. So what I'm going to do here is we have this Chrome device prepared coming in from Indonesia. And I'm going to do a login for this one. Okay, so that's the first login for this user that we've seen. This is a new user ID, and we're kind of establishing a baseline, just getting to understand this user exists. We've built a profile for this user. We have a profile of the device that's associated to their account now. And let's see what happens if I log out. Now I'll add a device, this time coming in from Sydney, Australia. We have an Android device coming in, or I can even do, another Chrome one, for example. We'll do a Mac one this time on Chrome. We'll create this device, and let's see what happens if now I just log in from another device for this same user. Okay, and you can see this time I get challenged. So this time again, the login succeeded as being sent over, the security solution is validating that, and it realized that there was some sort of anomaly here, and it challenged the login. It's forcing you to go through a 2FA challenge. But again, if I go back to my normal device, that Chrome one in Indonesia, and I reattempt that login, oh, typed in the wrong password that time. There we go, and I've logged in. So this is really cool because it gives you the ability to recognize when there's an attack and apply friction on the attack without applying friction to the good user from their good devices. So it allows you to do, it's almost like an invisible CAPTCHA in that scenario, where all the security is invisible. It's behind the scenes. You're not applying any friction when it's not needed, but you still have that intelligent engine that can recognize, something's a little fishy for this user. Let's do some step-up authentication at this point. Now, of course, with everything, there are some weaknesses here. What you noticed was it does need a bit of a baseline. I had that first login for the user. And then after that first login, it was able to determine that the next login wasn't normal. It was an anomaly. So it does need a bit of a baseline pattern. It needs to build this profile, build a portfolio for the user, understand what devices are normal for the user, what locations, what behaviors. It does strengthen over time. So the earlier you get it in place, especially if you're a growing company, if you're expecting, explosive growth curves, you want to get that in place from the start, because that way you start to build these profiles for the users early. Maybe you see those users the very moment that they're registering for an account, and then you actually have them protected from day one. So that's just one caveat with UBA, is it needs this baseline. But if you get it in place early, then it really strengthens over time and can protect a solid user base. Another downside is it requires, similar to ML, huge data sets and live data sets. you're looking up these individual user profiles in real time to figure out if there's any anomalies. That can be very expensive to set up, very expensive to maintain. 5 years ago, this started coming about, but it was more used for, protecting internal employees at a company. But when you want to roll this out for consumer grade security, and you're talking about protecting a consumer base that could be for a given application, tens of thousands of users, hundreds of thousands of users, tens of millions of users, it's very expensive to run that at scale. So you need a solution that was really designed from the ground up for consumer scale and not necessarily just for protecting internal enterprises that maybe only gets to a couple hundred or a couple thousand users. You really want something that can scale to the tens of millions very easily. So going through this, I hope we were able to kind of showcase a few different tools and helps you to kind of think about what exactly are you trying to protect against. That's the most important thing. If you're protecting a user base, if you're trying to increase your effectiveness in different realms of security or against different types of fraud, what is the location you're really trying to reinforce? Because there might be a different tool that's better to tackle the job at that location. Castle really tries to make this easy for developers. What we do is we utilize all these different techniques, all these different tools within one clean API. It's a single API where you don't really have to mess with everything that's happening under the hood. The credential stuffing detection and the ML kicks in when it needs to kick in. That UBA is there and gets deployed when it's ready. And if you're going to do more on like registration spam and you want to apply more of that context awareness and doing email validation, that's there with a single click out of the box. So what we try to really do at Castle is understand what's happening in each of these attacks and what's the best tool for that job. And then ultimately we try to package that up into our platform, hide the guts of it behind a single API that's easy for developers to implement. And that way you can just turn it on and not really have to worry about it, not really have to maintain it. I hope this was helpful. I hope it was helpful to see some demonstrations of some of these things in action. And if you have any questions about where Castle might be able to help you in particular areas, please let us know. You can reach us, support@castle.io. Thanks.